Asymptotes at one end. One. Nice little drawing here. Each one, there's no open dots. Nothing crazy. So if I want to pick x equals 0. Here's where x equals 0. Then y equals 0. If x equals 1. There's x equals 1. What do I find? Does not exist. There is a vertical asymptote there.
Wait, don't cry. Why?
Why what? Because there's a vertical asymptote and there's nothing to pick.
Okay, that's what I thought.
Yep, there's no train tracks or anything.
Asymptote threw me off.
Now it looks like I'm going to 1 from the left, from the right, and overall. So here's my place I want to go to. First one, get on the train just on the left and ride the train until you get to that line. What's happening? You're going to negative infinity. The other one, just get on the train just to the right, ride the train towards that line, and you're going to positive infinity.
Did you just understand it today?
Therefore, overall, one train goes that way, the other train goes that way.
Can you make a name for that?
Does not exist. What?
Denny.
Random Jenny out of the word? What's
Denny.
Denny. Oh, okay. I thought you said Jenny. I'm like, well, I don't know what the Jenny Sabrina has to do with this. Negative infinity. Negative infinity is over here for x. You ride the train towards that line, and your y value is 1.
Wouldn't it be 1 Nick?
Oh,
Oh wait, never mind. Sorry, I was thinking something
That's
different.
where that line is right there. Positive infinity is over here. Write it until you get to a y value of 1. Yep.
Did you move 1 or do you really mean 0?
I meant 0, mainly to confuse you. Because most of the time we go after the asymptote, don't we? Alright, second graph. This looks a little bit normal, but you've got this little point right here. And we'll talk about that when we go to the continuity. But, pre-calc question, if I pick x equals 0, here's x equals 0. Do I find anything? No. Does not exist.
It does not exist because that isn't removable.
That's not, removal has nothing to do with pre-calc.
What? We're in calc.
Yeah, but this is a pre-calc question. You just got to pick x. So all that stuff you've got about removables and all that, that's not applicable at this point. That's an open dot, does not include it. Yep. If there wasn't an open dot there, it was nice to be negative 1. Now, here's where you got to watch out. Most of you would have thought, it's just going to put the 1 here, because that's what we've been doing. I did 0 from the left and from the right and 0, just for the heck of it. So, I'm really looking to approach the y-axis, right here. Coming in from the left, get on the train just to the left. And what's my y value? Negative 1. Get on the train just to the right. Don't get on this train. That's not, you won't get there. Got to get on this train. And you ride that train to a y value of negative 1.
Why do you get on that train?
Because that's the only one that's going to get to x equals 0. This train doesn't get to x equals 0.
Okay, that's where I was confused.
Yep, you can't. This train does not take you to the x equals 0. You can't. You got to get over that red line. This one's going to take you
What if
towards.
there are none that equals go to 0, then it be does not exist?
What do you mean? None. What do you mean? I guess I don't
Like if
understand.
there weren't any trains that took you to 0.
There wouldn't be a question then.
Oh, they wouldn't do that to you. But would it have been does not exist if that happened?
I don't even, if it doesn't happen, there's no reason to answer that question, you know what I mean?
Okay, I'm
Yeah, if it's not a question, there's no reason to
It
think about
just
it.
crossed my mind.
Yeah, but don't even think about it, otherwise, yes.
So what questions do the open dot part like apply to?
Pre-calc questions. And a continuity thing.
When you say
With limits,
Okay. They don't, it doesn't matter which.
right.
Oh, right.
So, let me finish this out. If this is -1 and that's -1, 0 is -1.
When you say pre-calc,
Go ahead, yep.
the f of whatever, that's the pre-calc, not
That's
the
just the
limit.
pre-calc stuff, yep.
Okay, not the limit.
Not the limit, that's calculus. All right, positive and negative infinity. Negative infinity, over here, goes to 0. Positive infinity, goes to 0. Right? Now, continuity stuff. Using these two graphs. And let's look at the first one. Are there any places where this is not continuous? Okay, at x equals 1. So this is not continuous at x equals 1. Is it removable? The only way it's going to look removable is going to be something that looks like that one on the graph. Algebraically, obviously, it's going to cancel out.
Only at X.
Yes, you're only worried about an x value for continuity.
So you don't have to worry about the Y.
Nope.
Okay.
So when you're asking continuity, you're talking about the dotted line.
Breaks.
You can't cross the dotted line.
I'm trying to decide, can I pick up, or take my pencil, draw the whole thing without having to pick it up.
Okay.
If I have to break it up, it's not continuous anymore. It's a continuous line. Otherwise. The second one. Any places where it's not continuous.
1, X equals
1 and also
1.
0 for x. It's the x value. That open dot and the dashed line. So we're not continuous at x equals 0 and 1. From the graph, this one, since it's boom and boom on either side of it, that is what we called a removable.